Hi, I'm Dr. A.J. Kumar, PhD. Not 100% sure what I'm going to work on. I guess this is ophttpd 8, maybe? I think I did 7. And I'm going to try to remember. I was very sleepy and tired, and I don't actually really remember what I did. Apparently I got WFC kind of working. So what I might do is use this opportunity, because the WFC code base needs to be redone. And let me explain why. So, just a fundamental rule in Erlang is that you can never have your users input atoms. Now, you're not going to directly trigger a bug doing that. It's perfectly fine. There's a function Erlang list to atom. Let me zoom in. There's this function Erlang list to atom foo. And it creates an atom. An atom in Erlang, the atom foo means foo. It doesn't mean anything else. You can't index it or anything like that. It's not a string. It's represented internally, I think, as an int. Looks like I gotta sneeze. I can't find a Kleenex. God damn it. There we go. Hi, sweetie. Come here, kitty. My cat heard me talking and has decided to come see me. Hi, kitty. Come here, sweetie. I'll blow my nose. You hear the cat purring? Sweetie. You're the best kitty in the world. Alright, the problem is that the atoms are stored in some sort of table, and so it makes you vulnerable to an attack. Now, I think you'd have to, the point is the attack vector is there, and you just don't want to leave attack vectors open. And so the table will just build up forever and ever, and they never get deleted from the atoms never get deleted from the table. And so, sweetie, you're the best. So anyway, the problem. Let's go look in the WFC codebase. I'm going to start a new tmux. This is a bug in WFC net as well. So let's go work through the code. So if we go to okay, so I always say start at the top level module. This is a library, it's not quite the same. Alright, so we've got my quote here, which is a good quote. Every operation, calculation, and concept, no matter how arbitrarily complex, reduces to adding integers together. There are no new concepts in QAnal. Everything is just putting lipstick on adding integers together. Now, if you're not familiar with WFC, I did a long playlist about trying to explain it. Now, it's based on, it's some software that does, what's that guy's name? Norman Wildberger's improved version of Boolean algebra, which I call WF algebra. So let me just briefly explain the basic premise of it. So I'm assuming you're familiar with modular arithmetic in general. If you're a programmer, you know what modular arithmetic is. You know what the mod operator does, at least. Okay, so what this guy realized is that you can at least do Boolean logic entirely in modular arithmetic. So typically you think about Boolean logic, your kind of three basic operations are inclusive OR and not. Okay? And what he realized is that it's actually a lot better if you take out inclusive OR and replace it with exclusive OR. And and not. And let me just show you an example. So what I'm going to do is use this framework. So the reason is that if you do this in Mod 2 arithmetic, these three correspond to the operation plus, the operation times, and adding 1. Sorry, my cat is rubbing her cheeks against the pen, so I might. Anyway, so here's an example of what you can do with it. So I'm going to prove that if A implies B and B implies C, actually here I'm going to prove something simpler. A implies B and A, this collectively implies B. Now let me show you what this means in WFC. So I can go here. So and A implies AB. So we can see implies AB. I already typed this in. Let me make it really big. I already typed this in. It corresponds to this expression, and I'll show you how we get there in a minute. But we take and A implies AB. Well, let's type that in. That's times AB. Does this imply A? Yes. This means yes. Because this means 1. It's the sum of the empty product. The empty product is 1. And then you take a sum of 1. So, and I'm going to explain, well, when we go through the code, you'll understand why this notation makes sense. But let me just prove this within WF algebra. So first of all, we define, so each of these things can have the value 1 or 0. So okay, but let's define what implies means, and let's write a truth table for it. Okay, and so 0, can I please write 0, 0, 0, 1. I'm not going to do my good ones. I'm sorry, I just don't have time. Let me, I want to write the truth table like an Erlang function. Let's call it impl. There we go. Okay, so implies means if the first is true, then the second is true. So if the first is true, then the second is true. Well, that's true here. If the first is true, and then the second is true. Nope. If the first is true, then the second is true. Well, the first is false, so sure. If the first is true, then the second is true. 1. And you can take this as the definition of the implies operator. Now, what I'm going to do is I'm going to call this x, and I'm going to call this y. Okay? Implies xy. And I'm going to show you how we go about. This is a bad example because it's going to be kind of laborious. But I'm going to show you how we go from, this is how WFC works internally, and then we'll see the code. So what I'm going to do is I'm going to say implies of xy, and I'm going to write it in a weird way. I'm going to write it as I00 of xy times impl of 0, 0 plus I01 of xy times impl times implies of 0, 1. So this is just a function, and it returns either 0 or 1. Plus let me now I'm going to explain this in a minute. Okay, I need to zoom in. Y there's a thing where you warm up, meaning if I've been writing for 20 minutes, my handwriting is much better than if I've just started writing and I just started writing. Okay. So, what is this? So what is this? What is it? What are these I's? These are called indicators. Now, what I00 is defined as, so I00 of x and y of 0 and 0 is 1, and I00 of the others, of anything else, is 0. That's what this means. Okay? And so, and these are called indicators. So it's 1 whenever it equals its own whenever it equals its own pattern of arguments, and otherwise is 0. So if you think about it for a second, I'm gonna be using this space for a moment in a minute. So okay. If you think about it for a second, this is kind of obvious. So this identity. So what I'm saying is that because each of these argument patterns are disjoint, so exactly one of these i's is going to, so for a given x and y, exactly one of these I sub whatevers, exactly one of these is going to be 1, and the others are going to be 0, in which case it will be 1 times the value of the function. Okay? Now, the key thing is we know the values of the function, and it's pretty easy to cook up these indicators. Does that make sense? Okay. So, you know what? I think this is the way the original WFC worked, and that's not the way that this works. But anyway, the current version works. I need to kind of rewrite it, and so maybe we'll take this opportunity to rewrite it. Anyway, let's see. So I00, this is going to be 1 plus x times 1 plus y. Would you fuck off? Oh, I don't actually have to fuck off. I love you. Okay. So this is going to be 1 plus x times 1 plus y times 1 plus 1 plus x times y times 1 plus x times 1 plus y times 0 plus xy times 1. Okay? It's the same logic as down here. Exactly one of these indicators will be 1, in which case it's 1 times the value of the function. We can just straight away delete this term. We don't need to worry about this because it'll be something times 0. There is a trick where if you get the opposite of implies, then if you have a go watch the podcast if you want to get that trick. I'll try to remember. I will link the podcast for sure. Anyway, so what we do is we now take this expression. So in pole of x and y is equal to 1 plus x, 1 plus y, plus 1 plus x times y plus xy. Okay, and then and then we're just going to expand this out. So this will be 1 plus x plus x. So 1 plus x plus y. So that's oops. Okay, I did this wrong. First, inside, outside, last. Plus, okay, that one's easy. Y plus xy plus xy. Okay, now we use the fact that in mod 2 arithmetic, anything plus itself is equal to 0. And that's equivalent to saying that if you take an odd number plus an odd number, you always get an even number, or an even plus an even, you always get an even. Because that's what 0 mod 2 means you're an even number, odd mod 2. 1 mod 2 means you're an odd number. That's what modular arithmetic is. Modular arithmetic is the generalization of that idea. So we're going to cross out pairs of things that match. Okay? And then this y gets crossed out with this y, and I think we're left with 1 plus x plus xy. So if we do impol of a and b, this should be 1 plus a plus ab. Okay? And if we go back over to here, hey, that's what we got. 1 plus a plus ab. Okay? So what I'm going to do is, what we're now doing is testing. So we're trying to evaluate implies and a impl a. I'm going to use lowercase. Implies ab. Does this imply b? Okay. Well, if we take implies AB and it with A, that's equivalent to multiplying it through. So let's switch to a different color. So and A plus 1A AB. Okay. This is going to be equal to, you know what, I need to use standard math notation. My brain naturally can do normal math notation. I'm going to switch to lowercase letters, but you know what I mean. This is and A. Okay, this is equal to A times 1 plus A plus AB, which is equal to A plus anything times itself equals itself. So 0 times 0 is 0 mod 2, 1 times 1 is 1 mod 2. So in other words, anything A squared is equal to A. A plus A squared B, which is just AB. And this is equal to AB. So in other words, this is saying that both A and B are true. Well, now we ask the question, does this imply B? So now we ask the question, let me switch to a new color. Impol, and instead of and A, blah, 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 I'm going to write AB, B. Okay? And this is going to be, well, 1 plus AB plus AB times B, right? Because it's 1 plus X plus XY. 1 plus AB times B. And, well, this is 1 plus AB plus AB. Cross these out, and this is equal to 1. So that's a proof. A statement is true in WF algebra if when you evaluate it, it evaluates to 1. It's kind of cool. Okay. So there's a bunch of new features I want to add, and I want to make the language a real language. It is really shitty right now. Here, let me just show you. So if I type in 0, it'll evaluate that to 0. But if I put a space before it, it chimps out. Okay? And it's just, it's terrible. So I don't know if this is the time to fix that type of bug. But this is a demonstration of kind of the idea of WF algebra. And all of the other, go read, I'll try to remember to link it. I elaborated this really well in Revelations 14. Not in the Bible, my revelations, not the Bible. But mine are better than the Bible's, although I have not read the ones in the Bible. And so, I need to read the Bible. Let's see. Okay. Anyway, that's what's going on here. And so I wrote a library that does this type of manipulation in Erlang. That's WFC, the WF compiler. And then I wrote a string parser on top of it, and the string parser is terrible. The library is pretty good. There are a couple of features that I want, so implies it will. I think this will just be a parse error. Yeah. So I need to think a little bit more about how this language is supposed to work. Oh, and that's 3%. Let me go plug this in. What did I want to work on? I think I wanted to just clean up my website a little bit. But this is something to keep in mind. This is what WF algebra is about. And it was, I think Norman Wildberger came up with it. Let's see. What am I going to do? I mean, I think honestly that this is good enough. I mean, it's Chaba dual, but scrolling would be nice, but it's not mandatory. Okay, wait, I have a fix. It's a shitty fix, but it's a fix. Because the problem is that if you use this for a little while, it becomes kind of unwieldy. So, I have an idea. Here. There we go. What I'm going to do is I'm going to move this input up here. There we go. Huh. You bitch. Just eating wrapping paper. Okay, and then let's try this. Okay. There's no actual session that goes on behind the scenes. Okay, there we go. Make it a real language. That would be nice. Okay, and then this proof that I just did, and a okay. I don't like that numbering thing. That's kind of stupid. Okay, this is good enough. Alright. That fixes the pet peeve I had. I would like when you hit enter, but as long as it keeps a history, I don't really care. What are you eating? Anyway, let's see. You know, you can also just do exactly the same type of algebra. I was just showing it's just high school algebra. And implies BC. Does this prove, for instance, that, so A implies B, B implies C, does that imply that A implies C? I can check this. Okay, I would like if when you hit enter it would submit. Yeah, I'm gonna add that. All right. What is it called? This is wrong. I liked this a little bit better. And I'm going to copy code from Stack Overflow. That's funny, is Stack Overflow is completely useless for Erlang. I'm going to use this. God, I'm becoming a JavaScript faggot. Anyway. Let's do it this way. I hate this thing where you drop down. There's no good way to do this, is there? I'm just going to have to deal with my shitty aesthetics. There, that's better. Key press function E if E dot key equals equal. Triple equal, that's right. Some JavaScript retardation with double equals. That's right, okay. Go away, WFC. I think I'll fix it. Yay, that works. Alright, my cat, I think, is hungry, so I'm gonna go feed the cat. I think, what I'll do in the next video is, she heard the word feed, I think, is, update my website, because it has an old, this code has an old site tree for my website in it. Alright, I would also like if there was a way for me to upload a tarball via SSH or something. I don't know. Anyway, alright, that's all I have for now. Thank you. Bye-bye.